Welcome back. So far, what we have observed that whenever we have some kind of system, that is, and most commonly in this course we are using dynamical system. Okay, so what what basically we are doing using the help of classical calculus and help of variational calculus, we try to model that system. Okay, so we try to do some kind of mathematical representation such that I can able to create some kind of virtual experimental setup with help of mathematics, and after that we can do experiment. Okay, so suppose if you have mathematical model, then you are able to understand that how to design control. You are able to understand that when there is no control, then what is response of that system. So modeling is very important. Okay, and in order to do modeling, we need a sufficient background of the linear algebra, some part of real analysis, and due to that reason you might have seen that I have given a lot of time towards the linear algebra. Okay, now in today's lecture I am going to talk about the system identification. Okay, again you can see system identification as a one kind of approach to model the system only. Okay, name is just different, but this is also one of the way to model the system might be a static system. A static system means, suppose that if you have some kind of resistor, and if you apply some kind of voltage across resistor V, then corresponding to that you are getting some kind of current across this particular resistor, and suppose this is R. So what happens that as you are going to increase the voltage, current is also going to increase. Okay, so but that is not depending on any past or future value. Okay, so always Vt is directly proportional to It. We have already seen. We are assuming that whatever resistor I have taken here, that is a some kind of linear like property. Okay, now suppose that if we are going to talk about the capacitor, at that time our situation is little bit different. At that time what happens that whatever, if I write like this, you can see that q equal to cv, and after that if I will write dq by dt, so that is I c dv by dt. Again I am assuming that whatever capacitance I am taking, that is constant here, means because we are calculating means capacitance like this. So if area is changing or distance is changing, then capacitance can vary. I am assuming that is constant, and due to that reason I can able to write like this. And if you calculate V here, so dV equal to, I have something like I tau by C and d tau, and I have to integrate from minus infinity to t, and at minus infinity I can assume that voltage equal to 0, and here I have voltage equal to Vt. Again if I will write it, so I have this kind of situation Vt, and here you can see that minus infinity, and suppose if I have started our experiment at t0, then I have I tau by C d tau plus t0 to t. Okay, so this kind of things we have already learned during circuit theory course, d tau. So this portion is nothing but Vt0. Okay, so it means that in order to understand the value of Vt at any instant, I have to know several things. And what kind of things I have to know? I have to know the value of capacitance, value of V0 at t equal to t0, then and current at each and every instant, then only I can able to predict the value of Vt. So this class of system is called dynamic system. So we have two different classes of system: a static system or dynamic system. Okay, and it is possible to show that, suppose that I have some kind of mass m, and now what happens that if I apply some kind of force here to this, so this mass is start moving. Okay, and and what happens that if you try to capture the movement of this mass, so using Newton's law I can able to do like this. Here one more thing is that suppose that if I am just worrying about the acceleration for this particular system, so what happens that you might have learned this kind of things, that suppose xt is the position, then I am able to calculate vt, that is dxt by dt, so that is the velocity, and after that I can able to define the acceleration. A is nothing but dv by dt, like that. Okay, so in order to calculate a, I have to solve this equation, that is d2xt by dt square. Okay, and due to that reason, now if you solve xt, then two unknown quantity that involve inside this equation. Okay, so we will see that how basically I can identify those kind of constant, such that I can uniquely predict the xt if I know the a0 or something. Okay, so I have two different classes of system, and after that we try to identify that system. Okay, so what is main objective? Main objective again of this lecture, to obtain an appropriate mathematical model of dynamic system. Okay, on the basis of observed time series. Okay, so I have some kind of time series of data. So suppose that if I have some kind of system, and I know this system. Okay, and after that, what I have some knowledge of system, and what I am going to do, I am going to do experiment with this system. So how to do experiment? I have just two channel. I have input channel and I have output channel. Okay, so what I am assuming, for each corresponding input I have certain class of output. Okay, and I know that kind of things by experiment. So once I know these things, later phase what I am going to do, I am going to identify the mathematical model of this system. Okay, and this is the basic idea of the system identification. Okay, and if you see nowadays, you might have learned about the data driven modeling, or you might have seen that neural network based modeling, or artificial intelligence. Most of things is basically based on this only. Okay, and if you see the literature, this is actually developed at least more than several years ago. Okay, and if you see the initial prediction, okay, before Newton's calculus comes into picture, before that also people are actually observing something. Okay, so for each time they have certain kind of observation, and based on that they are predicting some kind of behavior. Okay, so our ancestors are doing that. So if you see the data driven modeling, or data means, suppose that I have some kind of observation based modeling, that is very very old topic, that is not a new topic. Okay, so in this lecture we are trying to understand that some connection of linear algebra, okay, with this kind of observation. Suppose that if I have observed time series, and if I know periodicity some system, okay, then how to identify the model of that system, that is our main aim. Okay, so this particularly in today's lecture I am not going to talk about data driven modeling, means because whenever people are talking about data driven modeling, at that time they start talking about machine learning or these kind of things. Okay, I will take that kind of topic in the some class or next class, it might possible. Okay, so but in today's lecture we are trying to understand that if I have some kind of input data and output data, okay, time series means, suppose that if I apply some data here at some time, and corresponding to that I am observing something. Okay, and I have knowledge of the system, then how to get the mathematical model of this system. Okay, and during linear algebra course, okay, or during linear algebra lecture, we have already seen that how to solve this equation ax equal to y uniquely. Okay, we have seen when I was talking about four fundamental subspaces. that is related to this matrix A. At that time I have already talked about that. Okay, so we are trying to understand that kind of application in today's lecture. Okay, and due to that reason I have given several hours to explain that that what four fundamental subspaces associated with this matrix A and how to find the unique solution, provided this matrix A is not a square matrix. So similar kind of things is going to involve in this lecture, today's lecture. Okay, so before going to the actual problem, it is possible to show that this class of problem, when I know the system, when I have some kind of observed time series data, then that is topic of statistics. Okay, and in statistics one thing is called linear regression. Okay, and I hope that most of you is already familiar with linear regression. So linear regression is a linear approach for modeling. So some book, whenever they are writing modeling, they are writing MODELING or double LFO. So in this lecture I am taking both. Okay, the relationship between a scalar response and one and more explanatory variable. So we are trying to understand that what is meaning of explanatory means variable in subsequent slide. So basically I have some kind of dependent quantity and some kind of independent variable. Okay, so we have two different kind of variables. Some variable is known to me and some variable I have to predict whatever data I have from that data. Okay, and linear regression, the relationship are modeled using linear predictor function. Okay, and I hope that now you are able to understand what is meaning of linear. Whenever we are talking about linear, then I have to make sure that additivity and homogeneity both property will satisfy. Okay, so whose unknown model parameter are estimated from the data, and such models are called linear model. Okay, so in today's lecture I am just going to focus about the linear model only. Okay, so in order to understand the problem, what I am going to do, I am going to start with very simple example. Okay, so before talking about this example, try to understand some example like this. Suppose I have some kind of constant process. What is meaning of constant process? I have, this is some kind of process. Okay, and if I give some kind of input to this process, okay, so whatever output that I am going to get, okay, that input is basically, I am telling that is constant. Okay, whatever input you can give, I am just able to get the constant output. Okay, so how to model this system? I am telling that I have recorded output y1. Okay, and this process is constant, so I have something like x. But what happens that since I have to do measurement, so always error is associated with that. Due to that reason I have this kind of recording. Okay, suppose that if I will do experiment again, since process is constant, and due to that reason I am just talking about a static process. Okay, so a static process, again I have error like E2. Okay, so you can see here I can able to write this whole thing in form of matrix 2 like this, y2, and after that I have something like 1 1, that is multiply with x, and after that I have e1 and e2. So this process I have tell that I have some kind of constant process, so I can represent this as a yt, and I can give some nomenclature for this. So in subsequent slide you can see that I am going to give the nomenclature like this and plus e. Okay, so v is some kind of process I have, and what happens now here, you can see here that this variable 1 1 is called explanatory variable. Okay, for this unknown quantity I have to identify this unknown quantity x. Okay, because this unknown quantity x is associated with this process. Okay, but phi t I know. Okay, so from phi t, from experiment I know, and I have to minimize this error such that uniquely I can able to identify the output. Okay, let us try to see another example, little bit more transparent example here. So what I am assuming that I have some kind of object, and x is the position of object moving on a straight line with constant acceleration. I am assuming that whatever acceleration I have taken, that is constant, and initial velocity equal to x0 and initial velocity equal to v0. Okay, during school time also you have seen this kind of expression. If some object is moving with constant acceleration, then xt can be written like this, or you can able to drive, that is not very difficult, because a and d2 xt by dt square, and I am assuming that a is constant, so you can take one time integration. So if you take one time integration, then what happens that I have here what I have to do, at tau and 0 to t, and after that what I have to do here, if I will take one time integral, then this kind of things comes into picture, and some constant is also involved. Okay, and based on that I will get v0 plus half v0 plus at, and again if you will do, then you will get x0 plus v0 t plus half at square. I hope that you can derive this from here. Okay, so I am not going to write the detailed step. So here now you can see that I want to predict the futuristic position. Okay, so I have some kind of a scalar quantity xt, and I have some kind of system. So some object is moving with constant acceleration, and based on experimental data, now I have to forecast that if time is 5 seconds, then what is position of the object. Okay, so for that I am going to do, or I am trying to perform some kind of experiment. Okay, we will see that what kind of experiment we are going to do, but before that I am going to write this problem in some mathematical form. Okay, so from here you try to see that what I am going to do whenever I have some system that is moving here. Okay, so I will give some kind of input, and output I am going to record. So each time I have some kind of time, and for each time I am going to record the output of the system. Okay, so that system is actually moving with constant velocity. So I have clock, so t equal to 0 I have recorded the output, t equal to 2 I have recorded the output, t equal to 3 I have recorded the output. So what is my objective now? When t equal to 10, then what is my position? I have to estimate from the data only. I don't know what is initial velocity, what is initial position. I also don't know what is the acceleration. Okay, so I don't know anything. Sometimes what happens that initial position is known to me. Okay, so if initial position is known to me, then I will tell that okay, I have, there is no error associated with initial position, but it might possible in some problem I don't have knowledge of initial position also. I just know at t when I have started t, at that time what is value of this, t equal to 2, so I am recording the value. It might possible that particular object is moving in the past time. Suppose I start experiment at t equal to 5 second, but suppose object is moving from t equal to 2 second, so I have a start data that is started from t equal to 5 second only. Okay, so I don't know what is initial position at t equal to 2. Okay, so now what I am going to do, if you see the relationship between time and xt. Okay, so because here if you interpret this thing, then situation is looks like this xt. So what happens that time is independent variable, and xt, that position, is somehow dependent variable. So each time I am trying to forecast my position at t equal to 5 second, 10 second, 20 second, or 1000 second. Okay, now if you see the relationship between t and xt, so is it linear or non-linear? Anyone, could you please tell me the relationship between t and xt is linear or non-linear? Antara, could you please comment? Antara, are you here? Any other? Student Ayush, Ayush works. Could you please comment? Ayush, are you here? Bharat Bansal or Simran, anyone, could you please comment that what here I have written xt equal to x0 v0 t plus half at square. Okay, so relationship between t and xt is linear or non-linear? Quickly.
Non-linear.
Yeah, non-linear. This relation is non-linear. Okay, but whenever I have started this lecture, at that time what I have told, that I am going to use the linear regression. Okay, and due to that reason, now I have to reforecast this problem in little bit different way. Okay, and you can see here that if I will write yt again as a xt, but now if I select some kind of variable that is new, and inside new, if I will take this kind of column vector x0 v0 and a, and phi t, if I will select like this, now if I see the relationship between this new and yt. Okay, so could you please, and suppose that there is no error for time being, et or even if you can take error et, so et is actually depending on time. So could you please now comment the relationship between y and new, that is linear or non linear? Bharat. So xt and t is non-linear, but if you see now carefully, yt and new, okay, that become linear. Okay, so inside phi t it might possible I have non-linear term, but we are trying to identify those kind of component where I have some kind of linear relationship. Okay, and whenever I have some kind of linear relationship, then I can able to apply the linear regression. Okay, so due to that reason I have reformulated the problem. Okay, now try to I will define some kind of using this expression I can able to define the problem of linear regression is next slide. So same kind of things actually I have written here. If you see carefully, that this is means this is kinetic model, force is not involved here, just I am assuming that I have some kind of object and that is moving with constant acceleration. So this kinetic model is not linearly dependent on t, but linear in the unknown parameter. So if you see the with respect to time t, then this system is non-linear, but with respect to v, if I write in this matrix form, then that become linear. So relationship between output yt is nothing but xt here, so that is linear. Okay, so I forget to define this. Okay, and this variable phi t, which explain how basically each component of this column vector has certain kind of weight, and due to that reason this variable is called explanatory variable. Okay, this explain the weightage of x0, weightage of v0, and weightage of a with respect to time. Okay, and I have already told you that in each corresponding to each variable I have certain kind of error that is going to associate. Okay, so if I have precise measurement of x0, so I can assume that since if I will calculate something based on time series data, then in order to calculate a square, cube or something, always there is error, but one there is no error. Due to that reason people are assuming that E has zero mean corresponding to x0. Okay, now let us come to the, so this is this kind of linear regression model that is associated with this problem. Now I am going to define the general linear regression. I hope that some of you might be aware about this. So what basically we are doing, whenever I have some kind of system, we are trying to formulate some kind of a static relationship. Okay, here you can see that everywhere I have formulated the static relationship only. Okay, it means that based, if I will give t, then at that time what is xt, and after that we will collect variable in such a way such that I will get some kind of linear model. Okay, and so linear model with respect to some kind of unknown variable, and this variable only I have to now estimate based on the knowledge of 1 t t square 2. Okay, and I have already told you that each time I am going to record some kind of output. Suppose time slot I have selected 2 second, each 2 second, so I know t1 t square by 2 for each and every time. So based on that particular information and information of output yt, I am going to now forecast x0, v0 and a, and once you forecast x0, v0 and a, then you are able to forecast any value of xt in all future time. Okay, this is the main idea of the linear regression. Okay, so the linear regression model, with the assumption that model has unknown parameter nu I are explanatory variable of this phi, per explanatory variable phi 1 phi p is identified as follow. It means that explanatory variable is known to me and I have to estimate the unknown parameter. That is our basic aim. Okay, and here t, you can see that I have collected n number of observation. Okay, so in this lecture we are also able to understand that suppose I have some kind of process, then how many observation if I will take such that I am able to get the correct parameter. Okay, and here again aim is exactly same like the modeling. We know why we are basically doing modeling, because we have to identify or we have to forecast what is future value of the system for some time. Suppose this is the system, I have input and output, so I want to know that if I am at t equal to 5 second, 20 second or 1000 second, then what is my output. So exactly we are matching with same objective, and due to that reason we are telling that this is also one of the way to model the system. Okay, so what happens, I have to, you know, whenever I want to do this kind of modeling, first we have to set up the process, because if you are not able to set up the physical process, then you are not able to understand their behavior. It meant nowadays what happens, we have several simulator and they are creating some kind of virtual interface. Virtual interface means suppose you want to do the experiment on robotics, okay, or pendulum system or some kind of chemical process, or in on finance, then you have some kind of virtual way to represent that system, and after that we are applying or some kind of input, and each time I am going to record that output. Okay, and after that we are trying to model that system. Okay, so here whenever I am dealing with system identification, at that time I am assuming that model is already set up, either physical model or some kind of virtual model is set up inside our lab. Okay, now after that what is unobserved error, because whenever you are doing some kind of experiment, some kind of recording data or recording, then always error is there. So I can, if there is no error, so obviously that is fine, I can write y equal to phi and nu, but always error is associated. Due to that reason we are writing linear regression model like this. Okay, and v is v1 v2 vp, so p number of unknown I have, n number of observation I have, and based on that it is possible to show that whatever phi, that dimension is n cross p, because I am writing like this, so I have to become consistent. And here you can see that this is exactly situation is now like this ax, if suppose for time being assume that e equal to 0. And what is our problem now, I know y, I know a, but I have to estimate this value x. Okay, so again you have to apply the theory of linear algebra, and you have already learned about that when under what condition this has a unique solution. Okay, and what we found that if this y is going to lie in the column space, suppose that for example this is 3 cross 2 matrix. Okay, so 3 cross 2 matrix means I have this is 3 cross 1, this is 3 cross 1. So if this column and some number x, in order to understand the value of x, I have to make sure that whatever x, okay, if I apply x, then whatever space that is generated, okay, so this y should be lie in the column space of a, then only I have unique solution. So that kind of things is going to come in this lecture also, but here I have some kind of error, so I have to give little different interpretation. Most probably I will give that kind of interpretation in next class. Okay, so now let us try to see that what is our objective. At least I am able to formulate the problem. I have set up the process. Each time I am recording the output. Now what I have to do, from the output data I have to identify the parameters. Okay, so sometimes people are also telling this as a parameter estimation problem. Okay, so if I have knowledge of parameter, then I can able to estimate the futuristic data. Okay, but what is difficulty in this particular problem? Error is always associated. Okay, because we are performing some kind of measurement. So main goal is to minimize that error, and due to that reason I have to now take the help of some kind of node. Okay, because I have already told you that whenever I am writing yt minus phi t into y like this, so it might possible I have multi input multi output process also. Suppose I am observing multiple output at the same time. Okay, at that time yt, this yt may be some kind of vector. Okay, and due to that reason whenever I am writing here problem, you can see here that y I am telling y1 y2 yn. So whenever we are writing collecting the data, that should be actually collected inside some kind of column vector. Okay, so now what happens, since this y is some kind of column vector, so now I am not in one dimension. Okay, I am in higher dimension. Okay, and in higher dimension whenever you have to minimize something, then you have to convert your higher dimensional problem into one dimension problem, and whenever you have to convert n dimensional problem or higher dimensional problem into one dimension problem, at that time you have to take the help of node. Okay, so here we are going to take the help of least square. Okay, so try to see that what is meaning of least square. We are telling that a reasonable way to estimate the unknown from the given data to demanding that prediction error. Prediction error means this is my output, this is phi t is my explanatory variable which is associated with unknown parameter, and I have to make sure that this should be minimal, or in best case I am assuming that this zeta t is 0, then I can tell that exactly I can able to estimate this unknown from the known data yt, and this phi t is nothing but some kind of time series, time series kind of things comes into picture. Okay, now you can see that this is also called performance function or objective function if you see the prospect of optimization. Okay, so basically this is finite dimensional optimization problem. Okay, so now here you can see that since I am going to repeat this process for n time, and due to that reason each time I have to see the data, and after that we have to check that this is minimal. Okay, and due to that reason we are directly writing in matrix form. Okay, so in matrix form y is nothing but some kind of column vector, and phi vt and phi t, and after that we are writing y minus phi t. So basically zeta t, so if you take a and suppose c and d, and if you take the transpose of that, so a transpose and ab transpose equal to b transpose a transpose, due to that reason this kind of things comes into picture. Okay, and you know that whenever I have some kind of finite dimensional problem, okay, so I have some kind of function and I have to minimize that function. So I have to minimize this j nu. Okay, so whenever minimal occur, at that time gradient of j with respect to this quantity v should be 0. So at that point actually maximal or minimal that is going to occur. Okay, and if we do the second derivative test, means if second derivative is positive, then I can confirm that at that particular point I have minima. Okay, so same kind of things now I am going to do from here. One more important thing I am going to highlight here, please be careful here. This, even if this yt is vector, but whenever I am converting n dimensional problem into one dimension problem, so this is a scalar, so j nu is now real number, but this nu is a vector. Okay, so somehow j is mapping from Rn to R. Okay, now this is mapping from Rn to R. So you can see that after expanding this whole matrix multiplication, each and every term is a scalar only. Okay, so now let us come to the derivative of this, because I want to identify the maxima and minima. Okay, so suppose that if I have at nu, and if I take the derivative with respect to v, then this is a. Okay, so I hope that just what you can do, you can verify these two results just by taking any example also. Okay, that is not a difficult result. Okay, and this is vt and if you calculate the partial derivative with respect to v, so one time partial derivative with respect to v, another time with respect to nu. Okay, and after that this kind of expression basically comes into picture. Okay, and I have already told you that whenever you are going to open this particular matrix, so what I am going to do, I am going to multiply yt with y. So yt with this, and after that this. And due to that reason, I have written like this. Like this. Okay, so just open this particular expression that is written in matrix form. So basically either you can write in this form or this form, but matrix form is always very convenient. Okay, so you can expand it, and after expanding this, I am going to use this kind of result, since each and every term, because jv is a scalar, due to that reason each and every term should be a scalar. Okay, there is no exception on that. So if something is a scalar, suppose I have some quantity p is a scalar, then p equal to p transpose. So same kind of result basically I have used here. So yt phi nu. So either you can write yt phi nu or and their transpose. Okay, so if some quantity is a scalar, then one of the best test to see that that is a scalar or not, you can just do the transpose. Okay, now, but it might possible some quantity, you also well aware that some kind of matrix, symmetric matrix also they have similar kind of property. Okay, now here, so due to that scalar property I have written like this, and I have collected this term and this term together. Either you can write this term or this term, both are equal, and due to that reason jv is now y transpose y to vt phi t y and nu t phi t phi and nu. Okay, now what we have to do, I have to minimize this. So I have to minimize with respect to unknown parameter. Okay, so and unknown parameter is new here, and due to that reason I am taking the partial derivative with respect to unknown parameter. And now if you take the partial derivative of this, since there is no nu associated with y transpose y, that is 0. Okay, and after that you have to take partial derivative with respect to nu, and due to that reason 2 phi t comes into picture due to this result. And after that if you take the partial derivative with respect to nu, due to this result, this kind of expression comes into picture. If anyone had confusion, then please let me know. Okay, so now I have already calculated the gradient, okay, with respect to v. So once I get the gradient, then in order to talk about minima, just I have to equate that equal to 0. So if you equate that equal to 0, then you can see that this kind of expression comes into picture. Okay, and what I am assuming, that this particular function, okay, which is mapping from Rn to, so here I have supposed that v, I am assuming that how many data you have. If p data, then rp to r. Okay, so suppose you have n number of data, then that will map to r. Okay, so now I am assuming that minima occur in some new cap. Okay, and due to that reason I have written here that at new cap, when minima occur, then from this expression, if you equate to 0, then 2 and 2 is going to cancel out, and then I will get phi t, phi transpose t, phi and new cap. And new cap I am going to assume that there occur a maxima or minima. Again I have to do second check. Okay, because I have either you can either you can use the definition in order to show something is minima, or you can use the condition that second derivative that equal to positive. Then also you can confirm that some function means infinite dimensional optimization problem particularly, that I have some kind of minima. Another way you can show that this value jv is always least, gv bar is least among all, then that is the minima. Okay, so that is from the definition. So I have used from the definition because that is very convenient to use here. So what we have seen here, since I have to know the unknown, this parameter I have to unknown, that is unknown, and I know the phi t. Okay, I know the output y, whatever I have recorded. So from the phi t and recorded output y, I can able to estimate the unknown parameter. Okay, so unknown parameter is now a solution of this. So if you see carefully, then this equation is perfectly exactly like something like ay equal to x, something like that. Okay, and now I have to make sure that when unique solution occur. Okay, so based on the four fundamental subspace associated with A, you can able to comment about the solution. Okay, that when I can uniquely able to solve V cap here. Okay, so now in order to show that as V cap we have some kind of minima, so what I have to do, I am going to use the help of definition. So what I will do, I have perturb. So V cap I know, our new cap, this is new cap, basically new cap I am going to do apply some kind of perturbation delta V. You can either, it is possible that you can apply the negative perturbation too, that doesn't matter. Okay, it is possible to show that if you put this, then this kind of expression comes into picture. Okay, it is not difficult to verify. What you can do, you can just substitute in place of V, you can just substitute here both side. Okay, in this expression in place of V you can substitute now V bar, that as a like this V minus delta V, you can substitute that, or V bar. So I am substituting V new, so new equal to new cap plus delta V, you can substitute here in this expression. So everywhere you will new cap plus delta new, and after that collect all term. It is possible to show, so that kind of calculation I haven't written here, so please do by yourself. And now here you can see that this is always symmetry. Okay, so what is actually interpretation, since this is always positive, and if you see carefully jv is also always positive, because in that way only I have constructed jv, I have constructed here, that is zeta transpose zeta, so that is always positive. And due to that reason, if you see here, so for any delta v, it is possible to show that gv is less than, you can start with any gv delta j v j new cap, that is always lesser, and due to that reason I am telling that j new has minimum at new cap. Okay, in this way quickly you are able to confirm that at new cap I have minima, new cap I have minima or maxima, and we have minima only because whatever means new cap I will take, j new cap I will take, their value is least one. Okay, now I will take one example. So example I have taken whatever I have discussed just now. So what we have seen, that if some object is moving with constant velocity, sorry, constant acceleration, at that time I can able to model like this at square. Okay, and what we have done after that, we have written this problem like yt equal to phi t explanatory variable, and after that nu and plus e. So we have just seen when I have started the lecture, we have seen that this problem can be represented like this. Okay, so now what is our assumption? Since I want to identify this unknown parameter nu is here nothing but some kind of column vector containing x0, v0 and a. So I have to estimate this particular vector. Okay, so for that, in order to estimate this, I need some kind of experiment. Okay, so what I have done, at t that is 0, I have recorded what is my position xt. After 0.2 second, I have recorded my second position. 0.4, I have recorded my third position, and in this way I have created 6 number of observation. Okay, and how many unknown I have to identify? I have to identify the 3 unknowns. Okay, it is possible to show that number of observation should be larger than the number of unknown, then you will get best result. Okay, if that is lesser, then you will not get result, you are not able to estimate. Okay, and due to that reason you might have actually experienced if you are working towards the machine learning also, because that is also data driven approach. You have to train your model for large number of data. Okay, so here also similar kind of things is there. You have to perform your experiment on large number of data. Okay, and after performing this experiment, now what I have to do, I have to formulate phi. And if you see phi is nothing but 1 t square by 2. Okay, so what I am going to do now, based on this time series t equal to 0, I am going to substitute, and first term is always constant 1, second is 0 and 0. So I have substituted t equal to 0 in this matrix. So this is phi 1. After that I have created phi 2. So phi 2 I have to substitute 0.2, and due to 1 remains here, 0.2 and 0.2 square by 2. So due to that reason, in this way you are able to create this kind of phi, or explanatory, means matrix associated with explanatory variable you are able to construct based on time series. And this is known to you, because whenever you are recording some kind of output, at that time you are recording the time also, so it is easy to do. Okay, after that, now since I know the y observation, this is the observation, so I have recorded n number, n equal to 6 number of y, so that I am going to substitute. Okay, so I have to calculate phi t y. Why I am calculating this? Because you can see that I have to solve this in order to get v cap, means estimation of parameter. Okay, and due to that reason I have to solve it. So I know, if I know this and this, then I am able to write the v cap. Okay, and due to that reason I have calculated this and this two matrix. And after that, now process is very easy. What you have to do, you have to make sure that that phi t into phi, that should be invertible. Okay, if that is not invertible, then you have to increase number of the observation. Okay, and after that, what we will do, in this way I can able to estimate the v cap. Okay, after estimating the v cap, you have to identify the error also, and it is very now easy to identify the error, because you know yt and you know v cap, then you are able to identify the error. So you have to make sure that this error should be list. Okay, and here I have told you that this should be invertible. So how to check that? You can just make sure that phi t phi, that is positive definite. Okay, so if that is positive definite, and how to guess that is positive definite, just you can check the eigenvalue of some quantity, so that is positive definite. So in this way I can able to identify the unknown. Okay, and due to that reason, you can see that I have here calculated that mean square epsilon is equal to 0 and root mean square people are also calculating. Okay, so they are trying to make sure that root mean square, okay, that is least one. Okay, and phi t and phi doesn't depend on the number of observation, it only depend on the number of parameter. Okay, and phi t is symmetrical and positive definite, we have already seen. Okay, so now it is time to conclude the today's lecture. Okay, so what we have seen in today's lecture, suppose that I have some kind of process. So here I have taken the example of just a static process, you can tell. And after that, what we are trying to do, I have some kind of data. From data I trying to identify the parameter, and what we found that again I have some kind of situation like linear algebra comes into picture. Okay, now in next class I will tell you that under which condition I have unique solution or not unique solution. Okay, from here you are able to easily able to guess that if number of observation is very large, then whatever new cap I will get, that is more exact. Okay, so in this way also we are basically doing the modeling. Okay, or 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 since we are interpreting x0 v0 a in this particular example as a parameter, so most of time whenever we are doing this kind of mathematical model, we are telling that that is nothing but parameter estimation problem. Okay, so now lecture is in from my side. If you have any specific question, then please let me know. And same kind of approach you are able to see that in machine learning also there. So due to that reason, if you are aware about the available literature, then machine learning is not a very difficult thing. Any question? Okay, if you don't have any